Hi everyone. In this video I want to talk about the setting up of our measuring Planck's constant experiment. In this experiment we're going to take advantage of a property of LEDs where if you apply a voltage across the LED you can create a situation where an electron will drop from a conduction band down to a valence band. If we know exactly the voltage at which this starts to occur, then we can figure out the energy released by the electron as it drops down, which will then be the energy emitted as a photon when it drops down. If we know the wavelength of the photon, we can figure out the frequency, and from the energy and the frequencies we can find Planck's constant. These are the materials we're going to be using in the experiment. We have a battery and switch, a breadboard, an LED. We have 4 LEDs we'll be using. One will be red, one yellow, one green, one blue. They're all clear cap LEDs. A potentiometer, which is a type of variable resistor. And there are 4 leads that we'll use. In our leads, we have a plug on one end and an alligator clip on the other. This is a breadboard. Breadboards are useful for creating simple circuits without the need to solder. In this breadboard, each vertical group of 5 holes is joined underneath by a conducting material. The top 2 and the bottom 2 rows are also joined underneath the plastic mesh by a conducting material, but we won't be using these in our experiment. This is a potentiometer. A potentiometer is a variable resistor. The potentiometers we're going to use can vary between 0 and 1000 ohms. Every time we start taking readings, we want to start at the highest resistance available so that we don't damage our LEDs. For the potentiometers we're using, when you have them set up in the way that we do, having them completely rotated clockwise will give you the maximum resistance of 1000 ohms, and then slowly turning them anti-clockwise will reduce the resistance down to 0. This is a clear cap LED. You'll notice it has a long leg and a short leg. The long leg must always be pointed towards the positive supply from the battery. The short leg must always be pointed towards the negative supply of the battery. LEDs are very delicate. If you apply a very large voltage across them, then you can damage them. We try to avoid this by always starting with the strongest resistance from our potentiometer. In our experiment, we'll be using an ammeter to find the point where current just begins to flow through the LED. At the voltage at which we see the current just beginning to flow, that's the threshold voltage that we're going to be interested in. So the ammeter helps us to keep track of the current flowing through the LED. The polarity that you attach the ammeter matters. It's going to be attached in series, and you usually start with the 5 amp scale and work your way down. But because we're dealing with very, very small currents in this experiment, we'll be dealing with the 50 milliamp scale. But I would say that usually when you're using an ammeter, you always start with the largest scale first and work your way down. A key measurement that we want to make in this experiment is the voltage, the minimum voltage at which current starts to flow through our LED. This minimum voltage, also known as the threshold voltage, will be taken from voltmeters. The voltmeters will be applied to the circuit in parallel to the component we're measuring, which is the LED. The red terminal of our voltmeters will be attached to the positive side of the LED. The black terminal of our voltmeters will be attached to the negative side of our LED. And we'll be using the 3 volt scale on this voltmeter. Okay, here we go. We're going to start setting up the circuit. In step 1, we're going to connect the positive lead from the battery. The red lead is the positive lead from the battery. We're going to connect the potentiometer and the LED, all of them, to the breadboard. Here's a close-up of that situation. The red battery lead is the positive lead. We're going to connect them to column 30 on our breadboard, so they are now connected because they're connected to the same column. The potentiometer lead, which is connected to column 30, is from the middle pin of the potentiometer. The side or right-hand pin lead of the potentiometer is then attached to column 22, which is also attached to the long leg of our LED. Next, we'll start setting up the ammeter. So the red 50 milliamp terminal of our ammeter is attached to the same column as the right leg of our LED. Here's a close-up of that situation. In this image, we see that they're both attached to column 13. We can close the circuit by bringing the black negative terminal lead from the battery and attaching it to the same column as the black terminal lead from the ammeter. So the ammeter is in series with this simple circuit. When we do turn on the power at the switch, we must make sure that our potentiometer is completely turned clockwise so that it's giving the maximum resistance to protect the LED. In this image, you can see the LED is a blue LED. Here's another view of the closed circuit. You can see in the ammeter there's really not a lot of current going through this circuit, and yet we're still getting a bit of light through the LED. Here's another view of the closed circuit to help with your wiring. Now we're going to attach the voltmeter. This is the final component to be added to the circuit. We're going to connect the voltmeter across the LED, have a close look at how the wires are attached. So the voltmeter will be in the same column. One lead will be in the same column as the LED and potentiometer. One lead will be in the same column as the LED leg and the ammeter. Here is another view of that to help you follow the wiring and trace out where everything should go. Here's a close-up view for that wiring. So the positive terminal of the voltmeter is attached to column 22, and the negative terminal of the voltmeter is attached to column 13. Now that we're set up, it's time to start taking readings. We're looking for the threshold voltage at which current starts to flow through the LED. But this can be very hard to pinpoint. So the way we're going to do this is, starting with the maximum resistance on our potentiometer, we're going to take readings of voltage and current repeatedly as we slowly reduce the resistance from the potentiometer. This will allow us to create a curve of current against voltage supplied for the blue LED. Once we create this curve, we can then extrapolate the curve to find that point where we would expect to see the threshold voltage. We will repeat this procedure for each of our different coloured LEDs, the green LED, the yellow LED, and the red LED. Each time we change over an LED, we don't have to pull apart the whole circuit. We can just simply remove one LED and replace it with the next. The wavelengths of the LEDs are provided for us by the supplier of the LEDs. And using the wavelengths and the threshold voltages of each of these different colours, we'll be able to find Planck's constant. We'll talk about how to do that in class. So this video was intended to show you how to set up our experiment. I hope it was useful, and I'll see you soon.